So, good afternoon, friends. Today we have joined another on our session, Contact Session 6 on designing on-site sanitation systems, and specifically we'll talk about containments. And we'll be talking about planning for sanitation on-site and off-site systems, the code of practices, the guidelines, etc. We will do in a kind of a panel discussion where we'll be talking of. We have several experts with us. We have Mr. Venkatakrishnan from Bill and Melinda Gates Foundation. He comes with a rich background in new product development and technology commercialization. Has worked on different geographies, having different parts of global renewable energy majors, including Sun Edition, Interphase Energy, among the others. He's passionate about inculcating sustainability as a guiding mantra for corporates and government institutions, thus contributing towards global climate change. Presently, he is in the role of Senior Program Officer, and Venkata helps with the commercialization of transformative technology solutions in sanitation and reinvented toilets. We also have with us Mr. Sun Kim, born in South Korea and has graduated from the University of Washington in 1984 in mechanical engineering. He is a senior program officer at Water Sanitation and Hygiene team of Bill and Melinda Gates Foundation, working as a product development and compliance manager. Joining the foundation in 2014, he supports the foundation's effort to provide access to safely managed sanitation as a member of the transformative technology commercialization teams, and manages philanthropic investments in the area of international standards, implementation, testing, and certification, as well as reinvented toilet development and commercialization, working with R&D organizations and companies. With this, I would hand over the podium to Professor Chari to take over. While we do have other experts to be joining. Let's as they join, I might introduce them. Over to you, sir.
Thank you. Josna, just check if Dr. Rohit Kakkar would be joining a little late. What time? So ideally, he should have led the session, but yes. Dr. Rohit is slightly delayed because of his small government engagement. He will be joining shortly. So friends, it's an honor and pleasure to invite the leadership team from the Bill and Melinda Gates Foundation, who deals with standards as well as transformative technologies. And subsequently, we will also have Government of India representative from CPHEO, Dr. Rohit Kakkar, speaking about Indian standards, both from on-site systems as well as standards with regard to fecal sludge septage management. Now, this is a very important session for us. So far, if you recall, we've been going in a very gradual way, starting from what is citywide inclusive sanitation. We then looked at the key components of citywide inclusive sanitation when we started looking at how to plan for what are the tools available and how do we plan for CVIS in a city context. Now, one of the important building block in all this is to make sure that on-site systems work well. On-site systems where 70% of urban India and almost 70-80% of Nepal, Bangladesh, where most of us are coming from, is heavily dependent on on-site systems. So in that context, what sort of innovations are coming up, what sort of innovations are required is something very, very important for us. Right now, we are heavily dependent on septic tanks. But I think the septic tank technology is pretty dated. We need to start reinventing it. We need to start re-engineering this whole solution. Subsequently, we transport this waste and then it is full of pathogens. And then we use different solutions without addressing the pathogen content as part of the biosolids. This is another unfortunate area. Both the region, this whole region has no standards for biosolids, unfortunately. And then we don't even look at pathogen reduction as a criteria for selection of solutions, selection of treatment solutions. On top of all this, We don't have standards, both national and international. We have not adapted those standards, both from on-site systems as well as for the fecal sludge septage management. So imagine not having a standard and we are just embracing whatever comes our way. I think it's a high risk situation. So to discuss this, I think today's session is super important for all of us in terms of understanding what sort of innovations are coming in this space, on-site sanitation systems, and what sort of standards we need to embrace and adapt to our local context, without which we are not sure about the reliability, we are not sure about the quality of services that we deliver to the cities and the city government. So with this, I would now invite Mr. Venkata to take us through briefly about the innovation solutions that you are leading and your partners are leading. And then after that, I would invite Mr. Sumkim. Over to you, sir.
Thanks a lot, Professor Chari. This is a wonderful opportunity. So an honor to be here. Thanks for inviting me to this esteemed discussion. And also, I think you set the context really well, as you always do. So it makes our job easier coming into what we are really going to talk about. So I think exactly what and warm welcome to all the participants as well. It's glad to see so many officials from across the region, and it's like Professor Chari said, something that we feel is extremely important. And this is what led the Bill and Melinda Gates Foundation to really embark on a journey to try and address a very critical need of the society, which is the safe containment and treatment of in non-sewer areas with on-site sanitation systems. There are multiple solutions which exist, but they really don't address the problem on hand, which is making sure people have better lives, they have better access to public, the public health impacts are, the negative impacts are minimized by having the right treatment system. So that is the goal with which the foundation started the Reinvent the Toilet Challenge, or we call it the RTTC. And then that led to a lot of brilliant minds coming together, working on solutions that actually address the problem of containment and treatment at the point of generation of the human waste, which is within the toilet, or within the facility in which the waste is generated, and make sure that the waste is treated to standards which are treatment norms are set up such that they are completely safe to be either reused within as a resource. Could be the treated biosolids, their fluent liquids and so on, or they can be very safely discharged into the environment without having harmful germs get into the system. So that was the goal, and I think over the last decade or so, we, along with the partner network, I must say, have made reasonable amount of progress in getting now to solutions which can be placed in the field, and we are in that process in the last 2 years. I'll request Jyotsna to please pull up these slide decks for the discussion, please. Thanks. Can you go to the next slide? Yeah, so this is just general overview of how the whole world is sort of placed with respect to sewer coverage. So as you can see, large parts of the world have less than 50% sewers. And if you look at India, Nepal, Bangladesh, and the surrounding regions, I think we are anywhere between 20 to 40% sewer coverage. And with the ever-growing population, it's going to be extremely difficult for us to set up sewer networks, simply because we have there's so much disruption to economic activity and the kind of capex that is involved. It is really a wise thing to do if we can set up on-site sanitation or non-sewer networks as the population grows, as cities expand, especially the peripheral areas, the rural areas, and so on, so that we can really have access to safe sanitation, very safe treatment of human waste, ensuring that there's positive impact on public health. At the same time, it's also economically viable. So that is sort of the ultimate goal. And I think non-sewer sanitation will be the way forward. And it will help us to leapfrog a lot of the infrastructure, costly infrastructure changes that some of even the developed economies had to do. And this is a great opportunity for emerging economies to really learn and replicate and move forward in a very safe and sustainable manner. Next slide, please. Yeah, so this frame reinvented toilet, it was coined, I believe, by our co-chair Bill Gates and Melinda Gates when I think the goal was that over the last, that the toilet system that we have been using, the flush toilet, hasn't seen any meaningful change in its design over the past 100, 200 years, we must say. It's just been a flush toilet that was invented, I believe, in the 19th century. So really, Mr. Bill Gates really wanted to see how we can dramatically change this thinking, see how we can really get shrink the sanitation value chain to, and the ultimate dream is to have a system that can do all of the treatment within the point where, within the toilet bowl itself, as a back-end unit, and make sure that people can have these units, all people can have these units, access to these units. And then if essentially it means that there is resource recovery, water recovery, and you don't really need, you can be an off-grid toilet system that does the entire treatment over there, so that there is no need for any kind of external treatment. You don't need to take the whole waste to any other facility to treat or so on. So that is the ultimate vision, ultimate dream. We'll see a few configurations in this presentation, but there is a path to getting to that, and we'll talk about that during the course of this presentation. So as you can see, the FSSM value chain. So I think many of us might have seen this. It starts with containment at the point where the waste is generated. It gets into a on-site system, which could be a holding tank, a septic tank. Then it's emptied and transported to a treatment facility, and then it's reused or discharged. So as you can see, there is a lot of intervention points here where the people have to deal with harmful germs and pathogens, as Professor Chari said. We'll have people going, emptying the septic tanks, taking it, and then taking it over to facilities for treatment. So the reinvented toilet aims to shrink all of this plus the treatment into the first, the red dotted box over there. Yeah, and this whole infrastructure shrink essentially means not just freeing up a lot of bandwidth and a lot of economic resources, but also makes it a very efficient way of treatment, so that you end up having a lot more a smoother way of dealing with this with the issue of used water and biosolids, which will also make it very, very effective in terms of treatment, making sure that what goes out of the facility is completely safe and harmless. If you go to the next slide, we can actually see how it's shrunk here. So as you can see, the manual intervention, when the touch points, essentially containment is equal to treatment. That is sort of the philosophy of the reinvented toilet. So basically what is emptied out of this system is, or you could say, class A biosolids that are pretty much free of pathogens. So anybody can come in, comes into contact with them. They're not exposed to any specific risk of infection or germs. And then it just makes the whole thing so safe. And the good thing is, last 10 years, we've had a lot of, I think, exponential growth or exponential improvements in terms of how the treatment has been sort of getting better. And today, we really have solutions that have been tested in the laboratory, in the field, demonstrated. We have a few systems in India, in Bangladesh as well, and South Africa, which really are showcasing the application of this in residential communities, in public schools, in public toilets, community toilets, and so on. So really, this is something that will help, when in the context of citywide inclusive sanitation. So basically, to reach sanitation services to the last mile, it's going to be all next to impossible to really have, even if you have sewer networks, that's not going to reach the poorest of the poor, whom we really want to serve, the poor communities, the low income groups, and so on. But these systems, excuse me, are really going to have, they're really going to provide access to, anyone and everyone that really has a toilet or has access to a toilet can have access to these systems as well. So essentially, it offers complete coverage of the population, which is what we all strive for as sanitation professionals. So there is no need for further treatment, and this really is sort of it when it comes to the reinvented toilet solution. So I'll go over a few configurations just to visualize what we really mean by this and how this can be a transformative sort of infrastructure shift, tectonic shift that can really, if it really can be implemented. And I think we are at an inflection point where, essentially looking at it as a mission mode. So in the next 10, 20 years, if there is going to be significant coverage of these solutions into the population, then the kind of impact that it can have is going to be tremendous. So yeah, just the next slide, please. So these are some of the advantages. I think Professor Chari laid them out as well. Eliminates pathogens. Germs are removed. There are global ISO standards, which my colleague Mr. Sun Kim will talk about. and then it has it can operate off grid. So basically, the ultimate aim is to have a product which can operate even without the need for plumbing in and plumbing out connections. So I think that is sort of also is one of the thing. It's very robust, easy to install, and it is modular and takes it uses minimal water, so conserves water, which is a very scarce resource in all parts of the world, more so in the emerging economies, more so in South Asia and Southeast Asia. And of course, over a life cycle, if you look at it for all the reasons we mentioned, it has a very significant reduced lower life cycle cost as well, if you consider a 10-20 year. Next slide, please. Yeah, we'll just, like I said, we'll just go over a few, quickly go through some visualizations to see what this can actually help address. Yeah, so so black water, essentially the water that is generated in the toilets. So basically, if you look at it, just a pictorial of the household that you see over there. So before you have this, let's say when you're having a very regular toilet, you can see that there's a emptying truck that needs to come in, that needs to really take out the waste that is held in a tank, in a periodic manner. You'll have the water and the solid sitting there, and then you usually take it out for treatment. But if you go to the next slide, just to see visually how it changes. So you essentially eliminate the need for any kind of emptying trucks coming in for dispurging and so on. So basically, this will essentially have solids that are generated within this whole backend unit that you can see over there. People can continue to use this. It uses minimal water, recycles water for flushing, and then the solids are converted into some, depending on the technology, there are multiple technologies. You can have biochar, you can have, they all conform to some kind of class A biosolids, which are completely free of germs and pathogens. And then they can be taken and used for a lot of gardening and soil enrichment purposes, or even they can be just discharged into the environment without causing any harm. So that is sort of the level. So if you look at, this is pictorial of an individual home. So if you have a residential community with multiple stories and so on as well, you will still have very little used water coming out of the system. So basically, the sewer networks can get that much more shrink. You can have shallow sewer systems, much smaller diameter pipes that treat only the gray water that comes out of the households, multiple households, and goes to a central treatment. So there's a lot of ways that this can be worked. It's not a one size fits all. The technology enables you to do something that can really help with treating everything within the facility. And next slide, please. So a few other configurations. You could have a gray water and black water household. RT essentially is reinvented toilet as well. Again, as you can see here, you see a sort of an on-site treatment system over here in this part of the slide. And then this is before, like you have a usual setting. So, but if you go to the next slide and you see the impact visually after, so there that piece is completely eliminated. So basically, you can have this sitting. It could be at a household level with multiple toilets or multiple bathrooms, or it can be a building with 8 houses or so on. And you have a treatment unit that really the solids are separated, treated possibly at the place where, within the restroom. So you can just take it at the toilet itself, toilet bowl itself at the back end, or you can have it done centrally at a house level, or maybe at a floor level and so on. So the technology, the philosophy remains the same. Pathogens are removed from the solids and the water is treated to be reused. And some cases, maybe we need to have integrated used water treatment with gray water and black water. We already have solutions that exist for this. There are multiple solutions in the market today as well. But I think what this is trying to change essentially is address the need for making sure the solids are completely safe. They conform to really, kind of treatment that you see. Maybe you don't even achieve such treatment in Western countries today as well. So that is the kind of treatment that we really aspire to achieve with these systems. Yeah, next slide, please. Yeah, basically you see it neatly fits in anywhere depending on what kind of house, what kind of application you're really using it for. Extremely good fit for kind of facilities which are for public shelter, where people do get to shower, use the restroom and so on as well. So you can have, like I said, gray plus black water or just black water as the application comes for. Next slide, please. So this is like a quick picture of the demonstration that we have. The pictures of one of the reinvented toilets, which is more at a community level. When I say community toilet level or school toilet level. So as you can see, it's a containerized solution that can move from one place to another, that can be placed, fitted in where you need it to be, and easy to maintain. It just operates within a very constrained, optimized space, and does the treatment. And in terms of how it sits, it can be neatly placed anywhere, and it does the whole business without the need for septic tank or any kind of holding systems. And what comes out of this is rich in nutrients for the soil. So whatever the applications we can think of, we can utilize that particular material, or if it just needs to be discharged as well, absolutely safe to do so. Next slide. So before I jump on to the next technology, I'll check with Professor Chari if it's a good time to go there as well. We have time? This is the other one, which was at the FSTP level. What kind of treatment options exist?
So Josna, just down it for a minute. So we'll have just a bit of a conversation before we go to the next segment, which is about the fecal sludge treatment plant. So I think I agree, Mr. Nagendra, that some of the on-site systems, that septic tanks or pit latrines, they do have a treatment component. It is an anaerobic process, but the treatment efficacy and treatment efficiency, even theoretically, is much lower. Number one. And then septic tank without a soak away or soak pit is actually a disaster. It is as good as not having, it is nothing but a holding tank. So we need to take a leapfrog. And that's what I think what Mr. Venkata was talking about is a reinventing toilet. So just to sort of in a conversation mode, Mr. Venkata, what you're saying is the whole feces and the anal flushing, all of that is contained and treated in the same unit, and then the output will conform with the discharge norms. Is that what you're saying, sir?
Absolutely, Professor Chari. So basically what we have are, so like, just to set the expectations, is we have solutions which are currently at a community level, what we call the community reinvented toilet, that exists today, that can be put in the field. I think we are working with multiple partners, including ASCII, in doing some pilot projects as well for the government. So they are existing as of today, and you can take the anal flushing water plus the water that has flushed the feces, and then treat it and then convert that to completely safe dischargeable outputs, both the solids as well as liquids, which meet the highest global norms. But when it comes to the reinvented toilet at the household level, which, when I say this, I mean that sits within the restroom, within the place where people are doing their business. The technology exists, the prototypes exist, and it is for anybody to design it the way that it needs as per the user case. For example, you have the washers, you have wipers, and so on. And you have certain places where maybe they just need to separate the solids and treat it and let the water go through. That is possible as well. It's not necessary that. So we can have this system configured to do the way you want to in the context of the toilet usage itself. All the water treated or just the solids treated. So yes, sir, that's absolutely right.
So friends, what it means is currently we have a very dated systems, which are of course so-called gold-plated, where we shift the problem through pipelines and treat it somewhere else. And we also have on-site systems where we contain it and then hire a septic tank, a desludger, and then take it to a different location and treat it in a fecal sludge treatment plant. Now, the solution that Mr. Venkata was talking about, reinventing toilet, one of the solutions that he mentioned is to bring the whole process into the toilet block itself. And that is, I think, is fabulous for us. It is like a mobile phone. So it's completely no networks, no, tar, whatever we used to have in the past. Everything is contained in the mobile phone. The way we have a camera, we have a GPS, we have a conversation, we have a video, everything is coming into the same product. I think that is really fabulous. So the question, Mr. Venkata, is, I think our friend Mr. Nagendra is asking, is it a reality? Is it going to happen? What is the science behind it? It looks, it is not believable for many of us. So is it a sort of a near future, and what are the cost implications? Can it be made affordable to all of us? What is your thinking?
Yeah, sure. So 2 years ago, if this question were asked, so we would have been having sort of like a 50% thing on where we would have been. I mean, of course, this has been completely directly under the watch of Mr. Bill Gates. That this whole development has been happening. Lots of scientists. Professor Chari has been through the journey as well, and a few other experts in this panel. So it has progressed. We had this reinvent the toilet challenge in 2014 in India, in Delhi, and then 2018 in Beijing, and then all through lot of interest coming in from global sanitation experts and professors and so on. And today I can say that based on all that I've learned and kind of conversations we've been having with our partners, is that this is now at a stage where it's a design ready, that can be taken, productized and implemented, depending on how a company wants to really come in and do it. I mean, it's not available today, but I must say in the next 1, 2, 3 years, depending on how fast companies come, license this and take it to product, the version that you finally mentioned, Professor Chari, that is going to be within the restroom, within the bathroom, doing it. I'm talking only about that aspirational unit. That can be a reality definitely in the next 3 years, in a very conservative sense. 1 year optimistic, 3 years conservative, I must say, for sure. I mean, we just need the companies to come in, and I can also share that Samsung has taken a lead role in one of the development of one of these technologies, and it's public information. So so hence I'm sharing, and they have really they're looking forward to working with organizations to do some licensing and so on. And Sun Kim has been completely involved in the journey with Samsung. So maybe I'll let him also to help chime in. I see his hand up as well. So,
So,
and
Mr. Sunkin, could you like
yeah.
to respond? And also, can you respond? People are worried that it is completely patented and it is not available to most of us. Is it doable in Africa? So these are some of the concerns of our delegates. Could you like to clarify?
Yeah, before I hand over to Sun. Oh, Sunkim, please go ahead. Yeah. Yeah, you can do that. Yeah, go ahead.
Yeah, absolutely. As these questions are coming in, my brain is, hello everybody also. Yeah, my brain is wanting to respond. And the reality of it is, I think the cell phone analogy is ideal. If you think about today, what we have, a supercomputer in our hands, even the cheapest feature phones, and my wife calls the phone the camera now because it's more of a camera than a phone. But it really is amazing, because if you think about the cell phone, 30 years ago, it was extremely expensive and had one feature. You could just talk to somebody on it. And so that's really where we're at, where the technologies are ready to commercialize. The dream, my colleague Venkat is absolutely right. I mean, I think within a year or two, we'll have family household reinvented toilets. Community level toilets are already available, so they're available for purchase and installation. And the main thing in my mind is, does it work to the requirements, the standards that I'll talk about a little bit later, but also, is it affordable? And somebody asked, what kind of costs are we talking about? Initially, like anything that's being produced in thousands and tens of thousands, it will still be likely expensive, but the systems will be improved. And as hundreds of thousands and millions are being made, our goal, the foundation's goal, and the foundation tends to have big, bold goals, is 5 cents per user per day. Another way to translate it is that a family level 5-person toilet would be in the range of $400, $500 that you would pay to buy the unit, and then it would operate with less than 15 cents per day for a family of 5. So, but there's a lot of conversations that we can have about this. But anyway, I just wanted to.
Are they very, very energy intensive solutions? Or somebody asked, is it energy guzzler or is manageable?
Yeah, so the 5 cents per user per day, including CapEx and OpEx, is intended to include all servicing, all electricity. It's supposed to be the life cycle cost of a unit that should be, last for 10 years, absolutely. And Venkat mentioned Samsung. Yeah, Samsung has actually invested a significant amount of their own time at Bill's request to actually look into a technology, and their system which they are wanting to license to commercial partners that we're bringing to them. So they're using somewhere in the range of 4 kilowatt hours per day for a family of 5. And I believe because they did not optimize a lot of the components yet, it could be down to 2 or 3 kilowatt hours per day. The goal is to, of course, make it very, very small. And in fact, maybe in the future, even be energy positive, using the fuel, the energy content of human fecal material. So I'll stop with that. Thank you. Back to you, Venkat.
Thank you. Thank you. So somebody is already waiting to buy it. So there's already demand for. So friends, I think we also, when we look at the cost, we also need to understand that we are eliminating the pipeline cost and the downstream treatment cost, the road digging cost, the coping cost. There's so many other costs which often we ignore as a public service delivery. So if I convert that cost into and subsidize the household as an outcome subsidy, I think the price point can be brought down to very reasonable level. I think we need to think a little more creatively as government officials and start making it affordable to even the lowest of the poor, poorest of the poor communities. So there's 1 or 2 questions before Mr. Venkata on this, before I ask you to move forward. This is about, are these solutions also suitable for African cottage? We have some friend from Africa is worried that, whether this is only designed for South Asia or any of those, is it suitable for African context too? It's a global solution anyway, but yeah, I think it will be important to respond that it is. What is your thought?
Sure, I was just typing in the answer, but I think I'll talk through it. It's much better. So yeah, this is designed for all kinds of user bases. We call the washers, the wipers across the globe, and this has been set up. Goal is to make it economically feasible for Africa, for Asia, for the countries which needs them the most, with people that lack access to safe sanitation systems, like as you had seen in that particular map which we saw earlier. So definitely the intent is, the goal objective is to cover all these regions that need them. We have a strong presence working closely in South Africa, in Senegal, in a lot of African countries as well, out of Nigeria, Kenya, and so on, where we have a team dedicated looking at different use cases in Africa, as we are doing in Asia, South Asia, Southeast Asia, and so on. So there's no doubt that this solution is meant to be addressing the needs of all the populations, especially the low-income communities. So always we're thinking, I see a lot of questions on cost. Professor Chari neatly laid out that if you look at the life cycle cost, not just the equipment, but the displaced costs, which include the, what you're going to save in terms of reduction in treatment capacity, piping, and so on. So I think overall, out and out life cycle cost, or a complete, if you take a 10-year view, then definitely the costs are going to be, better than what we have today. And if we add the public health outcomes, then that's a no-brainer. But but just talking about just where we are, so that's the thing. And I see questions in terms of in terms of maintenance and so on. So I think ultimately,
and we will take up those questions as we progress. And
sure.
I think, friends, I give 2 more examples. We never thought we would have point of use water treatment. When you can have a water treatment in our kitchen, and we have a washing machine in our backyard, why not a toilet system which fixes our problem of sanitation? So I think this is a very, very exciting and hopeful times that we are going through. So Mr. Venkata, back to you. Till such time where we have complete point of use, the whole world is filled with these sort of solutions. How do we deal with fecal sludge to the desired standard? So what sort of solutions you have? Would you like to go to the second part of your presentation?
Absolutely, Professor Chari. And that's the goal with which we started out, this Omni processor, which is essentially, it is meant to be a very flexible unit that can help deal with, the intent was to offer a solution, maybe as the cities make transition, non-sewered areas get treatment at, you have STPs and you have so many other infrastructure. But then what happens to the really septage that is being collected from the multiple on-site containment systems, septic tanks, holding tanks? And how do we deal with this issue And maybe if I want to place this next to an STP or next to a municipal solid waste facility, can I offer something that takes both these wastes and then treats it? So multiple challenges were thrown at the scientific community, and we came up with what we call the Omni processor. We really zeroed in on two kinds of designs. But basically, they are separated by the physics. One is a pyrolysis-based design. The other is more of a combustion-based engine that helps deal with the fecal sludge. And it does all of it, which we discussed for the reinvented toilet at a community level. Basically, it takes in septage and fecal sludge and converts it into the germ-free, pathogen-free biosolids, and the water effluent can be treated to the quality we want it to be. We can take it as far as drinking water quality if you want to, and that has been demonstrated as well. So next slide, please. So basically, the like I said, the pyrolysis-based setup. So you have, if you look at like a block level, so you have solids coming in, that is being the one that is collected by the desludging trucks from multiple containment units, and then it is brought to the facility where the fecal sludge treatment plant is set up. And then you have it is dewatered, the outputs, as you can see, as it progresses from one block to the other. That is dewatering, then you get the sludge. The sludge is then dried to get to some level of, and this can be done on the same day. This is talking about real-time, same-day treatment. And then the pyrolysis happens, which is essentially controlled combustion with minimal or in the absence of oxygen, and then that converts it into biochar. And then the biochar essentially locks in the organic carbon into the output solids. And then that serves really as a very strong nutrient-rich material for soil sequestration, and helps with even making some of the barren lands fertile. It's got a very strong sort of benefit for soil. And then this also has some kind of the heat that is coming out of the dryer and so on. There is energy generation and reuse potential, which will help to run the from pyrolysis that can be used to run the dryer as well. And the water stream, of course, is separated after the dewatering, and it can go through in the kind of treatment that the city aspires for. And the water can definitely be reused for flushing and gardening and some kind of cleaning purposes. But you can take this further to certain levels and bring it to any level that you want to use. But again, that's multiple technologies exist for the wastewater treatment. And this meets the kind of treatment norms that my colleague Mr. Sun will be talking about in a bit, which is completely eliminating pathogens from the effluents coming out of this system, so that it is safe for human contact, it is safe for going into water bodies, to land, and so on. And what this is also a very climate resilient solution. So you don't have sludge sitting in a drying bed for a couple of weeks before it can really be somewhat safe to really handle and give away to farmers. Rather, if that is because we are in a region where there is lots of rain, a lot of flooding that's been happening, we're witnessing it, maybe outcome of climate change and so on. Having such a system essentially means the treatment happens on the day the septage is received. So basically, you don't have the problem of this overflowing into the cities, into water bodies and so on, and germs getting carried away along with them, as part of the feces, fecal matter. So this is a very climate resilient. As cities expand, as we are seeing in multiple shifts in the way we have climate cycles, extended periods of rain and droughts that's happening, a lot of flooding. So these would be solutions that will help handle that particular challenge as we make the transition to on-site systems that are, at the point of use, point of generation. Next slide, please. So some of the benefits, like I think we talked about it, all weather systems, it's value added, it's modular and scalable. So you can add more capacity as you try to scale this. We have this demonstrated in a few cities in India as well through our partner network. We have some systems in through that are being overseen by ASCII as well, and they are easy to integrate. And this can be, as you can see over there on top, it's like a containerized solution again. So very neatly laid out. The area that it takes can be 1/3 to 1/5 of existing conventional biological systems. So basically, it's a very neat facility that the way which is set up and looks, with a gardening thing that can be put around it, and the treatment happens on the same day the septage is received. So you're really looking at shrinking the timeline of treatment and keeping it extremely robust and resilient to any kind of flooding that we encounter on a lot of occasions. And it can be done coming straight out of the factory, so installation times can be quicker and easy to operate and maintain as well. Next slide, please. So there's some examples. Maybe the population figures have changed as well. This is, the cities are growing, and as cities grow, we are also embarking on a few upgradation. So just like I said, this can be upgraded. You can really put in systems as populations grow or as the city's needs for FSM grow. What we see typically is that when an FSTP comes up, then the community is really energized to use that facility and have more of the sludge really going into that facility, and you solve the problem of dumping that can happen in places where it shouldn't be, like water bodies and so on. So we can add more capacity by just adding more blocks of these facilities, the containers that you can see over there. So that's one of the biggest benefits that we see. The next slide, please. Yeah, this is a layout of one of our facilities. So, it doesn't even look like a conventional treatment plant where you have large drying beds or, holding ponds and so on. The whole treatment can be shrunk into this particular, within the boundary of this particular thing. And it talks about all the different processes that we go through. But the essential, at the center of this is pyrolysis as a physics that helps achieve pathogen kill in this particular system. Next slide, please. So this is the other system that we have. We started out with designing something for a large city or, like a sort of large town, which will be a 200 to 600 KLD capacity. This is based on combustion. Again, this you might have seen the famous video where Bill drinks water coming out of an Omni processor, which is essentially taking in water mixed with feces, goes through this treatment unit. As you can see there is separate stream for water, and then the solids are dried, and then there is combustion happening through a steam turbine, and then that is again converted back. The steam is converted back into water, and then you have pathogen-free ash, bio ash that comes out, and then this also can take in dry segregated municipal waste, segregated and unsegregated. So essentially, if there is a system that we want to design that sits co-located with a municipal solid waste facility, so those can be designed as well. This can take solids, fecal sludge and municipal solid in different proportions and convert them, treat them together. There are multiple ways in which this can be designed to meet the needs of the city and where they want to put this application. At the heart of it is removing pathogens from fecal sludge and septic, but it can be combined with other systems as needed to make sure that it addresses problems, because cities might have specific needs as well. Next slide. So we have this again demonstrated in the city of Vadodara in Gujarat, state of Gujarat, and as you can see again, it's neatly laid out. You have it meets all the emission norms. You essentially see white smoke coming out of this, so it's really something that is fantastic in terms of how it has a positive impact on environment. You also reduce the emission of methane that happens in landfills and in the sludge drying beds and so on. So basically, again, this addresses all of that, plus it removes pathogens and offers water that can be treated for reuse. So the two main philosophies: resource recovery, both water and solids, removing germs, and space optimization. So this can be fitted in anywhere at an area that is 1/5 of what you can see in conventional system. Yeah. So this is some, I think on-site sanitation is the immediate solution for the reasons we discussed right from the time Professor Chari laid out that it's going to be expensive to dig up roads. A lot of economic disruption activities are going to be disrupted, but going this way will help us offer the best solutions available today, even compared to the Western world, and leapfrog the need for expensive infrastructure layout. So, and anything that goes distributed obviously is easier to sort of scale up and replicate in multiple parts of the region. So I think that the philosophy is very much analogous to what we had in the telecom revolution, information technology, and so on. So yeah, there is huge value in looking at these solutions and trying to see. Essentially, it will lead out to Mr. Sun's discussion now on standards on
Sure.
why we need to get this package inside.
Thank you. Thank you so much. I think this is useful. We saw one completely reinventing toilet solutions, which is point of generation treatment. And then we looked at the high-end treatment systems for pathogen reduction, both standalone system through pyrolysis, thermal system, as well as combining with the municipal solid waste. I think these are super useful. Now, I think it's very important to, before I invite, I welcome first of all, Dr. Rohit Kakkar for joining us. Sir, before I invite you, I would now invite Mr. Sun Kim. Sir, why do we need standards at all in this context of point of use generation as well as in the fecal sludge treatment systems? Do we need such standards, and what are the benefits of standards, both from a household point of view as well as from a sector point of view? So I think this understanding about standard is very, very limited in this region. So I think your session would be super useful to understand what these standards are all about, how do we implement these standards, and then how do we move forward from where we are right now. Over to you, Mr. Sun.
Yeah, thank you very much, and I'll try to go quickly so that Dr. Kakkar has an opportunity as well. It's really interesting, the conversations that's happening, and these are all the same conversations we're having internally at the foundation, the questions being asked as well as with our partners, and these are all salient points. To the point of standards, I think Professor Chari, you started by talking about what are the requirements, and so, on-site sanitation system, by the way, this is worldwide, whether it's, India, Africa, Southeast Asia, US, particularly for on-site sanitation, the requirements and meeting those requirements oftentimes is not very robust. And even in the US, where I live, many of these septic tanks with integrated drain fields, so these are typically anaerobic digestion, some are aerobic, they are leaking pathogens, they're leaking, it's quite early for me, nutrients into the land and waterways, and it's creating big issues. And then also there's, like Venkat showed, my colleague Venkat showed, the water scarcity is a big issue everywhere. It's not just India, it's not just Africa. The southwest of the US is going through a multi-year drought, and it's just a big issue worldwide. So this is systems that we believe will be beneficial to the entire world. It's so standards. ISO standards are by definition voluntary until they become implemented into codes and regulation. And so I'll talk a little bit about the implementation of that. But if I could have the first slide, it's so I'll just talk real quickly about the applicable ISO standards in all the areas we're talking about: fecal sludge management, as well as reinvent the toilets and the OP, or fecal sludge treatment unit. And then also how this really connects to this idea of innovative toilet systems that will serve all people. So I'll go to the next slide. So the first ISO 24521 is a guideline for management of basic on-site systems. And there are two connected standards related to the on-site sanitation. It really is about, how does a service provider perform the work to desludge or install on-site sanitation systems. The second standard there, ISO 31800, is for the fecal sludge treatment unit. This is related to the component that my colleague Venkat mentioned, or what the foundation calls the Omni processor. It is the unit that does the treatment within a larger fecal sludge treatment plant. And then ISO 30500 is the standard, the international standard created for what we call the reinvented toilet, or the non-sewer sanitation system. So next slide, please. So if you look at the ISO 24521 and its related guidelines, it really is about improving and optimizing the management of existing on-site systems, or what we typically call fecal sludge and septic management. It's about access to toilets. How do you perform the work of emptying and transporting, the treatment required, as well as disposable and reuse. And it's really to support the service and improve the service to those needing those particular fecal sludge management services. So we recognize that there are existing systems that really need improved services, making sure that the work is done in a manner that's clean, that is acceptable to the customer, and is done professionally. And so, to us, that's a key element of fecal sludge management, and these guidelines provide those. If a country or a state or city chooses to implement them in their regulations of how to provide these services. The next slide is related to the fecal sludge treatment units, and ISO 31800 is a set of requirements that defines the design, performance, and testing. So, you can have manufacturers build systems and make first-party claims about what it does, how it performs. But when we talk about those test requirements, we're always talking in terms of third-party independent testing, because without that, you have no assurance that the system is working at the get-go, as well as some level of testing to ensure it continues to operate throughout its life cycle. The ISO 31800 is technology neutral, but it does have specific requirements. The standard is really for prefabricated units, stick build, or where many treatment systems are typically built on site, and that requires a tremendous amount of engineering and costs associated with building it on site. So the idea here is to build as much of it in a prefabricated form. These are intended to be fairly large systems, treating approximately the sludge and septic from 1,000 to 100,000 individuals, maybe more, maybe less. But the key elements are that it addresses the pathogens, the pollutants, the emissions, and the utility or the business that's going to operate this, its operability. And really there's maintainability and ease of use. A key element, I think there was a question related to greenhouse gases and energy. While it may not necessarily be operated in that way, depending on the economics of the environment, it has to show the system within the control volume defined by the manufacturer, able to operate off-grid in a non-sewered environment. That means it needs to actually be either energy neutral. These are for the bigger plants, energy neutral, and also not require sewer. So the water that comes out, the effluent that comes out of the system, has to be safe for discharge in terms of pathogens, in terms of COD, in terms of nutrients. And finally, because these are industrial sized machines, as opposed to the household level toilets that I'll be talking about in a second, we expect that even if you meet the requirements, the local and national regulations affecting these big systems may significantly affect the design, installation, and operation. Why this is important is because if you're able to make, if a manufacturer who's going to install and or with partners and maintain, if they're able to make a one machine that can operate in many different environments, that would be ideal, depending on the market. But if they have to build a system for every installation, it will just be cost prohibitive. So this is a big element, and the question becomes, can the ISO standard, ISO 31800, and the local and national regulations align in such a way that the systems that are built could be acceptable, possibly in a transition time with future improvements. The next slide refers to the ISO 30500, and this is for reinvented toilets or household or small community level toilets. Again, it defines the design, performance, and test requirements in order to be able to certify to ISO 30500. It is technology neutral. It doesn't state it has to be a thermal system, a biological system, or some combination of that along with other technologies. And by the way, the foundation, we are working, as Venkat mentioned, with a significant number of technology partners and shifting into commercial partners so that these products can become readily available. These are explicitly for prefabricated toilets and treatment systems. It is key. Imagine the cellular phone or the mobile phone, Professor Chari, you mentioned. If you were to ask a manufacturer to make one just for you, that machine will be huge, and it'll be millions, if not hundreds of millions of dollars. Yet you can now buy a feature phone for in the range of $100. Sorry, I'm using US dollars. And there are really nice systems that are more in the $1,000 range. But it's the fact that you're building millions of them, and as an economy of scale, and also systems improve over time. So these integrated treatment systems, it has to address the human health and safety as well as the environmental. So the pathogen reduction in 4 classes: bacterial, viral, protozoa, and helminth. Key elements. Also the pollutants, whether it's harmful to humans or the environment, has to be addressed. Emissions, usability. The requirement is that it be essentially equivalent to a water flush toilet. The user experience has to be that positive, otherwise systems will not be used. And there are a number of other requirements in terms of odor, noise. Fundamentally not required to be connected to a network sewage or drainage system. In fact, the effluent of compliant systems, depending on whether it meets category A or category B, could be have unrestricted use, unrestricted discharge, because it meets a certain level of COD, or possibly for restricted use, whether it's watering gardens or underground discharge if it meets category B. But the key is in both cases that it be the pathogen reduction is such that that it is safe for humans. These are toilets at a household or community level, and the expectation is that compliance to the ISO 30500 should address most, if not all, local and national requirements. And the argument could be made that even if it doesn't necessarily meet to the letter some discharge requirement at a household scale, these will be far superior to any kind of pit latrines or septic tanks that require a frequent discharge and the costs associated with it. So next slide. This is just a quick snapshot of what ISO 30500 looks like. As my colleague Venkat mentioned, the idea is that on site at the home, it has the front end, the user interface, whether it's a seat or a squat plate or some other front end interface. It also does the collection and also does the treatment all on site. So what should come out of these systems are dischargeable effluent. A lot of the water is actually reused for recirculating. It's recirculated as the flush water. It's clean enough to be used as a flush water. And what should be coming out are either ash, if it's fully combusted, or dried, but the key is for the solids that it be pathogen-free. Pathogen-free is, is our mantra, I guess, we talk about. And then next slide. This is just, at the foundation, I worked at an airplane manufacturing company, Boeing, for 28 years, and we were in a very specific role, but there were others who played in many different areas of the aviation industry: regulatory, the financing, the airlines themselves, and then the customers, of course. At the foundation, by the way, we don't do the work ourselves. It's really our partners who do all this work. And so we actually work to create an enabling environment, as well as helping to make the marketplace ready. And this has to be a commercial venture ultimately. It is the economics, the business of these systems that will really create scaling, create opportunities for not just the users, but for businesses, local service providers to maintain, to continue to drive the industry forward. So, I just want to point out explicitly on the left lower quadrant, support implementation of the quality standards. These ISO standards, unless they're implemented and used, really are meaningless. And today, our partners who are designing the technology, commercial partners who are designing the products, are actually using these standards. And also, we are working with test, inspection, and certification company, actually creating lab networks to be able to do certification and also monitoring once they're in place. And on the right side, we are very interested in working with local and national governments to create a regulatory environment that recognizes these ISO compliant products as acceptable options to existing solutions, whether they're sewer systems, sewer toilets, or whether they are pit latrines or septic tanks. Any solution that helps contain and treat are acceptable. And also ISO 30500 compliant systems on the toilet side, and ISO 31800 compliant systems on the operation. So I'll maybe it's worth noting, we are also working with different development banks and financing opportunities, including with governments, because we recognize that the transition from when the industry is fully on its own, fully capable of sustaining itself, to the nascent situation where we're in, this transition is going to be very painful. It's not going to be easy, but we believe at the foundation, working internally, but particularly with all of our partners, that this is a possibility. So I'll end with that. So thank you.
Thank you. Thank you so much. Extremely useful. So friends, we heard about three important standards. One is 24521 and 3180 and 30500. You may be wondering why these standards are important. As Mr. Kumsum explained, these are important for ensuring standardization, quality, cost efficiencies, and these are very, very relevant. For example, if there was no energy star rating system in India, that energy efficiency standards for all our gadgets that we buy, whether it is a tube light or any other lights, we have a 3-star, 5-star. Now we really look up to the standards and buy the product. And because of these standards and guidelines, the competition has come down so beautifully that the market has matured, the costs have come down, energy efficiency has gone up. So I think these standards are extremely, extremely relevant for non-sewer sanitation, where India is completely on non-sewer sanitation, or when we are moving into the fecal sludge treatment systems. So one or 2 points before I request Dr. Rohit Kakkar to speak about India perspective. Mr. Kumsum, these standards are many cities, I mean, most of our delegates are from cities, particularly 24521. If they want to really go through this, what is the mechanism? Are there empaneled accreditation agencies available whom we can hire and get the standardization for our value chain? Or is it too difficult?
Yeah. So first of all, getting your hands on a copy of the standards themselves. So they should be available through your Bureau of Indian Standards. You can also buy them on the ISO website. And we've also partnered, with our American National Standards Institute actually to get discounted. The foundation is paying discounted prices so that if organizations want to get a copy of any of those three plus the two related guidelines, they are available, and I'll make that website available. So they're available for free because the foundation is very interested in having these standards be readily available. They are copyrighted, so each organization is allowed to grab a copy through ANSI. But please, feel free to get them any way you can. And there are a lot of resources. I'll actually, after this call, I'll send those to you, Dr. Chari, so that you have access to those and you can share it. And specific to 24521, I know that there are organizations within India who are applying those as part of their fecal sludge and septage management guidelines. So, and there are other resources as well. Yeah.
Thank you. So I'm just conscious of the time. Thank you very much, Mr. Sumkim, for generously agreeing to share the resources that we can disseminate to a couple of participants who are interested in it. Thank you very much. So friends, we will share with you where these resources are available. You can download them or you can procure them and then start looking at how these can be applied for your, in your real life context. You can also reach out to your, like in India, we have Bureau of Indian Standards. I'm sure Bangladesh and Nepal may have some entity which is looking at standards, and we can also look at collaborate with them. So thank you very much, sir. Now I invite Dr. Rohit Kakkar. Most of us know about Dr. Rohit Kakkar. No need for big introduction. We already introduced in your absence. Dr. Rohit Kakkar is from the Central Public Health and Engineering Organization of the Ministry of Housing and Urban Affairs, which is a nodal ministry on which provides technical support, technical advisory for various subjects related to urban development, particularly water and sanitation and municipal solid waste management. Dr. Rohit Kakkar has done extensive work and research in the area of comparative analysis of on-site and off-site system, and his perspectives are very, very important. And these perspectives are very important from the point of view of Swachh Bharat mission as well as Amrut mission that most of us are implementing. So without taking too much time, now I invite Dr. Rohit Kakkar to share his understanding and his guidance on how cities should plan for on-site system, what sort of code of practices they should introduce. Over to you, sir. Is there any power outage in the ministry by any chance?
I think so, sir. His screen would freeze.
Yeah, so
I'll just call him. I'll check with him.
I think there is. So there are some questions. Are these ISO standards certified to any product or systems by global consent or contextualized by respective government? Mr. Sumkim, would you like to respond to that? Sudhaji is asking.
Absolutely, yeah. So ISO 24521 being essentially a management guideline, I'm not aware that anyone certifies a organization as having compliant to that. That's really intended to be added to local or national guidelines on how service providers should do their work. But with respect to the ISO 31800 and 30500, particularly for the toilet, those are intended to be certified at the international level. For example, one of our big partners, TÜV Süd, TÜV-V-SÜD. It's a company in Germany, Munich, headquartered there. We're working with their office in Singapore, and they're actually setting up through the foundation funding a network of labs that will be able to do full certification, and TÜV Süd has an ISO certification mark that they will be able to put. And why is that important? Certainly, a fecal solid treatment unit where a industrial partner will be purchasing it, they will do due diligence. But as a consumer good, when you buy a cell phone or when you buy a car, it's very hard to know, besides what it looks like, what it costs, how it interfaces. It's very hard to know. Does it really perform the way you expect it to? Does it kill the pathogens? No individual is going to go out there with a kit to figure out, is the bacteria and viral load, acceptable for the output. So that's where a test inspection certification, a TIC, like TÜV Süd, and we welcome others to join this industry, to be able to test and put their certification mark. It gives the consumer and the buyer some level of confidence. So the short answer is yes, absolutely. These products can be certified at the international level, but also every country has the right to do their own certification work. So they could also maybe have a national certification as well. Yeah.
So can I say, is it like the emission standards for automobiles? There are global standards as well as the country can adapt Euro 3, Euro 4, Euro 5 standards, and then create competition, create a sort of mechanism through market forces so that the whole industry follows that standard for the common good. Is that the model you are suggesting?
Yeah, absolutely. So these ISO standards, again, unless implemented into national and local regulations and codes, are voluntary. And so the question becomes, will countries who need better on-site sanitation systems, will they apply these as is, readily available products from all over the world and from India, from countries all over the world, or will they require products that meet such a stringent requirement that basically the market, they're unaffordable. So there is a balance that needs to be played out. So in many country contexts, and even in the US, existing non-sewer sanitation systems, and certainly not sewer systems, are unaffordable. There are many places in the US where people basically have no access to safely managed sanitation. So we're expecting that compared to the alternate, ISO 30500 compliant toilets will be far superior and will be a better value for individuals as well as for the community.
Thank you. So friends, what it means is these are global standards, these are voluntary, but countries like ours, where we want to improve on-site system, we have to integrate in the national building code or come up with certain localized standards or integrate in the municipal acts so that they become part and parcel of the regulatory framework. So I think these changes have to be taken, but till such time these voluntary standards are available to us and we need to adapt them to the local context. I think that's a key message. Now, Mr. Rohit Kakkar, Dr. Rohit Kakkar is in, I think there's a power outage, major power outage in the ministry. So he may or may not be able to join. So what I suggest is if you have any questions, we will request both the speakers to stay on for a little more time. And then we will wait for Mr. Rohit Kakkar. Otherwise, we will take a session in the subsequent talk. So are there any questions? Anybody would like to ask any questions? Oh, you've exhausted all of them. Okay, so one or 2 points which I think Mr. Venkata has already sort of and now I think addressed, but I just for the benefit of everyone. Now there was a question about pyrolysis. We are taking the fecal sludge as a part of the OP. We're doing liquid solid separation. Solids are taken to pyrolyzer, and then the liquid is going through a treatment system as per your presentation. Now, the question was, is pyrolysis causing any pollution? Is it causing air pollution by any chance, or is it a controlled combustion? Would you like to speak a bit about it?
Sure, Professor Chari. So, pyrolysis essentially, as we all know, is as a controlled combustion that happens and lack of oxygen or minimal oxygen, and essentially it happens at temperatures that are north of between 400 to 800 degrees Celsius. And what it does is it traps the output solid that comes out of pyrolyzing the fecal septage or fecal sludge is essentially going to trap the organic carbon in the biochar that comes out. So we have tested this out on the emissions, and we don't see any of the significant greenhouse gas that is beyond the norms that you have for specific, ISO, that it meets ISO norms or even betters the ISO norms. So there is no problem of GHG emissions getting increased by using pyrolysis to train in an FSTP. If you compare that to conventional biological systems, I think which have a lot of methane coming out as well from the sludge drying beds. So you really see a very stark difference in terms of the emissions, and it also meets the ISO norms that Mr. Sun Kim was just talking about. So pyrolysis and gasification, both of them are very low on the emissions footprint.
Thank you very much. Now, there's one more point about energy neutrality. Somebody asked a question. Yeah, that does it require CTE, CTO before its installation? You mean to say consent for establishment and consent for operation?
Yeah.
Yes, yes, we need. Technically, all FSTPs, Mr. Vivek, require the Pollution Control Board approval. But many states do not take it, but the states where we work, we take it. Definitely, we take consent for establishment and operation. Yeah. So on the issue of energy neutrality, can these systems, can they become completely energy neutral? Is there any possibility?
So it depends on the capacity that we are talking. I believe at capacities, maybe the break-even capacity for energy neutrality that we have seen so far is between, I think, 60 to 80 KLD is where we see that the systems get energy neutral. Definitely the 200 KLD unit that we have in Vadodara is something that is definitely energy positive, energy surplus. We feed, at full capacity, it can feed back anywhere between 1,000 to 1,500 units of electricity back into the grid as positive energy. And again, it depends on the kind of septage you're receiving and so on, and what municipal solid it is co-fired with. For the pyrolysis-based systems, it is going to be a little bit of a challenge to have complete energy neutrality because of the kind of capacities they are designed to. They are much smaller in capacity. But however, in the transition period, we do have maybe some solar systems that are powering some of these OP pyrolysis-based omniprocessors. So they're green in terms of their operations, the energy that they use. Energy neutrality, well, it's still a work in progress to understand at what capacities we can achieve this. But so far, we've gone with the smaller systems.
So, friends, many a times we have this question. These mechanical systems, pyrolysis, they're energy guzzlers. How do we operate in a low-income country context when there is power outages? These questions often baffle us. So here the message is that there is a heat recovery system and which can be used to reduce a power load, number one. Second is for the larger size system, it can also become energy positive, as Mr. Venkat mentioned. So instead of consuming energy, you can put part of the energy that you generate through this system into the grid. So I think this is a future. So it's not always that these systems are high energy guzzlers, but it can also recover heat and also reduce the energy loads. I think that's a very important message. Somebody asked a question. So are there any other questions? Otherwise, I will pass on to Dr. Banerjee to make some announcements. I doubt very much whether if Dr. Rohit Kakkar would be able to join, because there's a significant power outage in the ministry right now. So he's not able to join, and neither he can take it from the phone. So I think that's where we need energy neutrality. So I think this is very, very important. So over to you, Dr. Banerjee.
Thank you, sir. Thank you so much. Just a few announcements on the assignment that was given. Of course, we have received around 30 submissions. There are a few more people who have not submitted.
70 we have received. 70 we have received, and we are yet to receive from 30 plus more.
And about the answers to that assignment's 15 questions, the multiple choice questions. After tomorrow's session, we would be discussing with you the results, the answers to them. And by tonight, by 12 o'clock tonight, the submissions should be there, because the link would be deactivated after 12 o'clock in the night. Please put in your submissions for the assignment. Another announcement that we need to make you is, as part of this cohort 4, we had planned for a study tour, and the dates have been taken up as 18th to 20th of October. So participants, mainly from this cohort, who are interested, we would invite your nominations. We would be sharing a link through WhatsApp where you can share in your interest and nominations. Jyotsna, would you put up the slide deck so that we can talk briefly about what we are going to do in these 3 days, 18th, 19th, and 20th?
And during the visit, they would also see one of the functional plants, omniprocessor plant at Warangal.
Yeah, absolutely, sir. So we begin with day 1, where we have a welcoming session here in ASCII, and then we take you to 2 different technologies at Uppal and Bodapal, which are the outskirts of Hyderabad. We would also take you to a co-treatment plant at Hyderabad, and then we would let you interact with the Hyderabad Metro Water Supply and Sewerage Board and the FSSM unit at HMWSSB. Day 2, we would be moving to our learning lab city, that is Warangal, where we would be seeing the public sanitation systems in terms of the public toilets, how they are monitored, the she toilets, the mobile toilets. We would be seeing 3 different kinds of systems. We would be seeing the Jocasso, which we have already discussed in one of our sessions. We would be seeing a soil biotechnology treatment system. We would be visiting 3 distinct technologies of fecal sludge treatment plants based on the pyrolysis, what we discussed today right here. We would be talking about the geotube technology as well as some other technologies. We would have an interaction with the sanitation workers, gender forums. We would work with have a talk with the environmental sanitation unit, as well as the city administration and the political leadership there, to understand how CWISE works in Warangal. And day 3, we would be taking you to the Commissioner and Directorate of Municipal Administration here in Hyderabad, which works with the government of Telangana, and then we'll be giving you the different ICT-based monitoring systems. And of course, we will initiate with a kind of action plan development, and we will discuss about what should be your next steps at your city level, how you should initiate. We would start working on that also. So this is our 3-day plan. The dates are on 18th, 19th, and 20th of October. Immediately after the session, we would be sharing you through WhatsApp group. We would be sharing you a link where you can put in your nominations, and then we can take up a call, and we will plan it out accordingly for these 3 days. Thank you.
Just one more announcement, sir, with regard to the logistics and all. So the travel arrangements are supposed to be made by the participants, and once they reach here, then everything is on us. Accommodation, food, travel, the local travel is on us. It's just the
so you need to reach Hyderabad, and then from Hyderabad you need to reach your place. Rest, once you are in Hyderabad, in Telangana, we take care of all the 3 days.
Yes. So there's one hand raised by one of the participants.
So this is like ISO standard. It is voluntary visit, but I think in this cohort we have added this field visit, so that seeing is believing. and we encourage all of you to join. This is an online course, but this is a blended learning model we are introducing. Feel free to join the study tour learning visit. We call it as Sani Tour. So instead of going to tourism places, you should now start coming to sanitation tourism. This is a future of the sanitation. Over to you, Josna. And Mr.
Nagendra Singh ji has a question.
Thank you very much, and thanks for this opportunity. Just I want to some clarification. So suppose, I mean, with me, some of the government official wants to come, because this is I find this is a good opportunity. Is there any scope for that also?
This is for participants, Mr. Nagendra. So if you want to bring, I think we will have a separate one-on-one call separately with you. From which state you want to bring?
Uttar Pradesh.
UP, okay. So we can figure out. UP is an important state, so we will figure out. I think there is a separate delegation coming from UP, but we would be very happy to accommodate. We'll find a way out. Let's
Okay,
talk
thank
separately.
Okay, thank you.
That's all for today, folks. So
Dr. Banerjee, our eminent guests are waiting, so you can thank them and then.
yeah, thank you so much, Mr. Venkat and Mr. Sun. Thank you so much for joining us and giving us such an elaboration of the things. That's all for today. We'll meet you again at the same time, 4 o'clock tomorrow with another session. Thank you. Bye.
Thank you, everyone.
Thank you.
Thank you. Thanks a lot.